Hi, we're going to talk about the sandwich theorem. So if we look at this picture here, there are three graphs, each of which represents a function, h, f, and g. Notice that h is always on top of the other two functions, or it's equal to. Notice that g is always in the bottom of these other two functions, or it's equal to the functions. And notice that f is always sandwiched in between the two functions. And the only exception is at x equals c. That's when the three functions all kind of converge on the same point of intersection. What the sandwich theorem tells us is that if this is true, so over some interval, if g of x, g of x is less than or equal to f of x, which is less than or equal to h of x, for all x not equal to c, so we don't really care what's happening at x equals c, and we know that the limit of the two outer functions as x approaches c is equal to the same value L, whatever that is, then we know the limit of the middle function must be L. And notice that's true. If we look at this limit here for h as x approaches c, h of x is approaching L. G of x is also approaching L. And so f must be approaching L too. That's the basis of the sandwich theorem. The question is, when is it appropriate to use? This is a great example here, this limit. The limit as x approaches 0 of x squared times sine of 1 over x. The difficulty of finding this limit without the sandwich theorem is that here, this part of the limit, sine of 1 over x, if we look at the graph, it looks like this. The function is kind of curving in, and then as we get close to 0, the function oscillates more and more quickly, up and down and up and down and up and down. It's going between y equals -1 and y equals 1. And the closer that we get to 0, the more it's oscillating. So it never fixes in on one specific value. Therefore, this limit doesn't really appear to exist, sine of 1 over x. And in fact, the limit as x approaches 0 of sine of 1 over x indeed does not exist. The question is, does this whole limit exist? Here's how we can use the sandwich theorem to help us. First, we want to come up with some inequality. And it is true that sine of 1 over x is always between -1 and 1. And the reason that's true is because the range of sine is -1 to 1. It's never going to be bigger or smaller than that unless we adjust the amplitude somehow by putting a number out in front. Now that we have that, I'm going to multiply everything by x squared. So I have -x squared is less than or equal to x squared times sine of 1 over x, which is less than or equal to x squared. And the reason that I've done that is because it gives me the argument of the limit, the thing that was inside the limit. Now once we have that, we know some stuff that we can mention. Okay, this limit here, the limit as x approaches 0 of -x squared, well, that's just a polynomial function. So we can just plug in 0 for x. We know that that limit is 0. Similarly, the limit as x approaches 0 of positive x squared is also equal to 0. Now, since both of those limits equal 0, and we notice that this function is always in between those two functions, with the exception of when x equals 0, because then this is undefined, we can say, therefore, that the limit as x approaches 0 of x squared sine of 1 over x, this is the thing that we wanted to find, is also equal to 0. This is the nature of the sandwich theorem. We state some inequality, we state the limits of the outer functions, and the limit needs to be the same, and then the limit of the function we wanted to find the limit of has to also be the same value. It doesn't have to be 0, it could be any L, any limit. Anyway, that's the basis of the basics of the sandwich theorem. I hope this video was helpful.